Hello YouTube, welcome to my channel. Today let's look at lead code number 6, zigzag conversion. In this, I first tried this version with initial implementation, and that actually gives pretty bad performance. And then this is the main reason is because I don't understand the Python internal how it handled the immutable operation on a mutable object. So this is actually the whole point of making this video. I think this is very important for whoever will be coding with Python for performance. You need to really understand how this works to improve your performance. So after I study this, I understand it, I make some changes to my code, and that actually improved the performance to 12 milliseconds. So I want to share what I learned with you. Hopefully, it will also help you to improve your code. So let's jump to the content. So what you see here is the first version, the one that has really bad performance. My original thinking was by observing the input and the output, I real I realized that we could actually give each letter a index based on the given number of rows. So we could actually, because it actually followed this kind of a pattern, if we give a number of rows to be 4, for example, and then we can actually start from 0, increasing to 3, and then decreasing to 1. And after that, it's always following this pattern. So it's straightforward thinking would be just to assign this pattern, each of the this pattern to the string. So each letter will associate with one index, and based on the value of the index, we could actually use the smart indexing in NumPy, for example, here to pick up the item. So for each of the row, and then concatenate them together. So that was my original thinking. And then I realized that because of the bad performance, I did some study, and then I realized that in Python there's a concept called mutable data's immutable operation. So in Python, we have two kind of data structure, immutable data structure and mutable data structure. Immutable data structure including int, float, those kind of simple data structure. So all the operation on the immutable data structure will create a copy. And for mutable data structure like a list, if we use, for example, for list, if we do append, that will not create a new copy. It will apply on the original one, unless until you read the maximum number, and then it will move to a new location. But it will not create a new copy. But for the mutable data structure, each of them has a bunch of immutable operation. This immutable operation, Python will actually create a new copy for you. So for example, for list, these are the immutable operation, including slicing, concatenation, repetition, sorted, and list comprehension. For string, we have also a bunch of um, immutable operation. So if we look at this two example here, the upper one uh, is basically we have an A there. We simply assign A to B. Uh, at this point, the second line here, it will not create a new copy. So basically, A and B, they both point to the same object, just with a different name. So in that case, if you append 4 into A, B will also have the 4 here because it's actually pointing to the same object. But here, if we using the slicing operation, which is a immutable operation, that means this line will create a new copy for you. So basically, A and B, they point to a different object. So here, if you append a 4 to A, it will not affect B. B will stay as it was 1 to 3. So with this kind of knowledge, if we look at my old implementation, we can see immediately a lot of problem here. So first, this one. So because we are using this repetition for this loop, that actually each of the loop it will create a lot of it will create a new copy, and so that's actually expensive. Then after that, I was actually trying to pick the length of the index with the same size as the string. That's yet another copy. And then when come to here, we first did a joint. So that's a immutable operation for string. And then we do concatenate inside the loop. That's another copy. So we made a lot of plenty of a copy here internally. So that's actually the reason why it's causing the slowness in the performance. So now let's look at the faster version. Let's ignore this line first. I will explain the difference later at the end. But if we look at the code, what I did is that I first check the corner case. If it's one, then we simply return the string. If it's not, we create a mem. Uh, the mem is basically a list of list, and inside that we have a number of empty list equal to the number of row. This memory is used to save for each of the row we want here. And then after that, we have this direction indicator because in this zigzag pattern here, we want to in the beginning we want to increment uh, the value, and after we reaching the maximum number of row, we need to decrease it, and then until we reach 0, then back again and come then this kind of zigzag manner. That's why we need to toggle the direction. When we reach the maximum, we actually need to make it minus so that when we accumulate it, we will get the decreased order, and after that, we will have the zigzag manner as we want in each of the memory. After finishing the loop, we come to this concatenating thing. What we do is that we actually do this two-level joint. First level joint is it joins the content of each the list, and then after that we join the whole thing together, then return the result. The one thing really that's another internal like handling for Python. I think it's also related to this mutable and immutable. It's the difference between this and this. So when I first implement this one, I actually write the code like this. So I was actually thinking to replicate this. So I will have a array with this kind of a setup. Um, but the difference between this and this is that if you use this way to generate the object, basically all these object they are actually pointing to the same object. So if you append a value, one value to this list, it will also append to the others because they are the same object. So that's actually not what we want. So in order for us to generate a list that each of these is a different object, we have to do something like this using the list comprehension to generate and based on the length of the number of this number of row. Only if you do this way, then each of the object will be a different object. So if you append something, it will only apply to the object to the row you wanted to append. So this is actually something also took me by surprise when I implement that one. I had a problem, then I debug it a little bit, and then I noticed okay that's the case. So again, this is because I don't really understand how Python internally work and how they handle it, but now I do. I think this is actually quite useful information for you guys as well. So yeah, that's what I want to share. See you in your next video. Bye bye.